Hello, everyone, and thank you for joining us for today's Fiber Broadband Association webinar. Today's webinar, Connecting Rural Communities with Reliable Future-Ready Networks, is presented by EXFO and Corning. I'm David Norris, webinar producer and virtual event manager here at FBA. And before we get started, I just have a couple of quick housekeeping items to ensure everybody has the best experience. So first, as attendees, you're in listen-only mode. However, we will be having a Q&A session near the end of the presentation. To ask your questions, you'll need to type them into the question panel, which is available from the control panel on the side of your screen. There's also a handout section, which includes a copy of our Fiber Forward magazine. This webinar will be made available on demand 24 hours after today's broadcast, and you'll be able to access that from our website. Just note that the on-demand version is available to FBA members only. And so if you are a person at a member company, you should be able to log into the website and access that replay. If not, you'll need to create an account on our website to do so. We're talking about connecting rural communities today, and we all know that millions of people in rural and remote areas still don't have reliable and affordable internet services. And so the question remains, how can we bridge that digital divide and bring high-speed internet to these unserved communities? So today I'm pleased to have Vincent Racine, product line manager and the optical business unit at EXFO, join us. And we also have Darren Howell today, the fiber to the X solutions manager at the Corning with Corning Optical Communications. So welcome to both of you. I appreciate you both taking time to join us today. And I understand that you'll be discussing the challenges and the different opportunities that we have for building fiber access into those communities. And you'll be focusing on key aspects, including the architecture and testing solutions that are critical to delivering reliable internet to these customers. And so with that, I just want to hand things over to Vincent to get us started.
All right, so it's a pleasure to be part of this webinar today. So I'll kickstart the presentation, and then we'll hand over to Darren for a section of the presentation. So glad to be part of this webinar with you. Thanks for attending. So the agenda of today's presentation is as follows. So we'll talk first about FTTH technology basics, and then we're gonna link with network architecture. So that's the part where Darren will jump in and talk about different architecture choices. Then we'll talk about consideration for building reliable, future-proof networks. We're going to touch base on best practices for accurate network assessment. So of course, in this section, we'll talk about different test solutions that are available today to facilitate testing and maintenance of today's network. And then we will wrap this up with a section on how we can ensure workforce efficiency through automation, not only at the test instrument level, but also at the workflow management and also the test instrument job management level. So we'll wrap up the section with something around efficiency of the workforce. So first, let's talk about different FTTH technology basics. So why are we choosing fiber as the medium to transport traffic today? Why are we saying that this is the most future-ready technology available? There's a number of reasons for that. We'll touch base on a few of those now. The first one is the fact that fiber is nearly unlimited in bandwidth. So as you lay down fiber today, this medium will be ready for future network capacity and future network improvement. It has a lower maintenance and OPEX cost than other traditional mediums such as copper and other technology. Fiber is virtually resistant, very resistant to corrosion and rust and aging. So it's virtually good for life almost. So that's the reason why we say it has a lower cost of maintenance, and also the fact that it's completely passive. So we'll talk about this later on in the slides. There's no active equipment in between the customer and the CO where the signal is transmitted, hence the lower cost of operating of OPEX and maintenance. It presents a very low latency, which is critical for live interactive platforms such as today in this webinar. You know, we're sharing video and audio Low latency is super important. Online gaming and all those new applications, teleworking are all very demanding in terms of latency. Fiber provides a very low latency, enabling those kind of applications. It's easily scalable. What we mean by that is, since it's built around a passive architecture, no active equipment in between the customer premise and the CO. That means that if you need to upgrade the network to provide more bandwidth, you can simply update the equipment at the customer location and also within the CO, so the transmission and receive equipment. Within the network itself, in the fiber plant, completely passive, as we said, nearly unlimited in bandwidth, so it's really ready for future-proofness or future applications. Fiber today can enable multi-gigabit speeds. That's a reality that we have to take in consideration. It has a very high bandwidth capacity. So today, if you want to upgrade to, let's say, 10 gig, 25 gig, or even 50 gig PON, which is already in the talk, fiber will enable this kind of transmission speed as it is today. So when we talk about a PON network, what is PON? So the definition of PON is passive optical network. This is meaning that it uses fiber optic components instead of copper. So in between the central office and the customer premise, it's fiber, splitters, patch cords and patch terminals. It's all passive equipment. So there is no active equipment in between the customer premise and the CO, such as amplifiers and components like this that would require power to be delivered at this location, hence higher OPEX costs. Fiber is completely passive on networks. It typically uses what we call point to multi-point kind of architecture. So this is meaning that we have a single fiber in between the CO and the first splitter that will deliver signals to a number of customers. Typically what we see as a fiber count at the customer level, at the split level, is maybe 8, 16, 32, 64, or even more than that. But these are the most common split ratio that we see out there. So that means that you have a feeder fiber before the splitter that would then be split at the distribution hub to deliver services to a number of customers, depending on your split ratio at the distribution hub. Using this kind of network topology greatly reduce network installation cost, management, and maintenance. As again, since it's all fiber built, it's really future-proof. So there's various components within the network, and Darren will touch base more in details around those. But the first one we want to highlight is the drop cable, which we also call the last mile connection, which is basically a cable that we install in between the customer location and the drop terminal. So generally speaking, we will install this connection when the customer is calling to subscribe to the service. If there was already a fiber service delivered to the customer, of course, this cable is already installed in place. Generally speaking, it is made of bend-insensitive fiber. It is ruggedized with a jacket that will protect it from environment and stress. Then you have fiber distribution hubs, or FDH cabinets. These cabinets will be placed within the network and will usually house the splitter itself, so the device that will take the signal from the CO and split the signal into various combination of 8, 16, 32, 64, or even more split ratios. It will also typically have a patch panel if it is a connectorized FDH cabinet. There's architecture that will also accommodate other capabilities, such as a completely spliced network. But a connectorized cabinet will offer great flexibility, as you can disconnect and repatch customers as your network will grow. You have also fiber distribution terminals, and these terminals will connect the drop cable at the customer premise. So a distribution terminal is usually also called a drop terminal, is usually installed somewhere close to the customer premise, ready to have a drop cable connectorized as the customer will subscribe to the service. All right, so now let's talk about network architectures. So back to you, Darren.
Yeah, thanks, Vincent. Thanks for leading us off here. So let's jump into network architectures. The main thing we're going to cover here as we jump into network architectures is kind of common or typical deployment architectures, and then talk about trade-offs and some considerations for different deployment architectures. So what you see on the screen here are typical or common deployment architectures, ranging from home run to centralized split and into two different types of distributed architectures. As you look at the icons on the slide, what we're trying to demonstrate here is there's a range of potential trade-offs in terms of time to deploy, total costs to deploy, and then there's also things to consider like how much fiber do you have in your network, OLT efficiency, and the labor and effort it takes to deploy these types of networks. So as we start off with home run architectures, this is the most fiber-rich architecture, where you have basically point-to-point fiber connections from the central office or head end all the way to the home. You might cross-connect somewhere in between, but your splitters are typically housed in the central office or at a central location in proximity to the OLT. So while this gives you the most fiber-rich architecture, it also typically takes the most time and has the highest total cost. So next up is centralized split. We reduce time a little bit and cost a little bit, and this gives you some flexibility. This is a point-to-multi-point, very similar to what Vincent showed in his slides. So we have a centralized splitting location in between the central office and the terminal or network access point out in front of the home. And most common architecture here is to utilize a 1x32 splitter at that central location, and typically pay as you grow. So you add splitters as you add subscribers and scale the network to meet the needs of your network. So again, this is kind of in the middle ground in terms of speed of deployment and total cost. It gives you a fiber-rich system as you have fiber dedicated between your central point and the homes, but the feeder gets a little bit leaner. You can use one feeder fiber to feed 32 homes in that scenario described earlier. The other thing to consider in this is that a centralized split is typically the most common architecture out there deployed today, and so that comes with its benefits. And then typically what we see is somebody may have started off with a centralized split, and they may be interested in the distributed architectures. So one of the things you have to consider is as you change architectures from, say, a centralized split to a distributed architecture, you've got to think about systems like your IT systems, your records management systems, and then testing procedures, which Vincent's going to talk a little bit more about later on. So your operational considerations. We'll talk a little bit more about the distributed architectures here in a minute, and it's just something to really think about as you're looking at ways to reduce costs, address workforce shortages, and find efficiencies in your network. The distributed split and distributed tap architectures present some interesting capabilities. So as we're showing here on the screen, the distributed split and distributed tap are typically faster to deploy and lower total cost. So these more fiber lean architectures really enable you to make a lot of use out of, say, a 12 or 24 fiber cable. So in distributed split, we have, as we're showing here, just 2 layers of splitting. So we go from one level of splitting at centralized split to now distributing it into 2 layers. And then with distributed tap, we have 2 layers of splitting, but as we'll show in an upcoming slide here, we introduce the concept of uneven splitting and mix kind of uneven splitting and even splitting. Again, 2 layers of splitting typically, but it really has a benefit that we'll show in a second beyond distributed split in terms of fiber efficiency. All right, so let's jump to the next slide. So with more rural networks being built and some of the economic challenges to reach the least dense locations, we're seeing more interest in these distributed architectures. And the primary reason is cost and efficiency. So as I showed in the previous slide, these two types of architectures do present the ability to lower total cost, and that's really what makes it attractive. But for some people, this represents a change, and so we're choosing to really highlight this architecture here for a minute to show what it involves in terms of the logical layout, and then we'll talk a little bit more about deployment considerations. So here we're showing a traditional even distributed split, 2 layers of splitting. The first layer we're calling 1 to Y, could be typically a 1 to 8 or a 1 to 4 split. And then your second layer split is usually going to be the reverse of that. So you're going to maintain that 1 by 32 split, which is similar to centralized split. You're just moving it in 2 separate locations. You could do a 1 by 64 logical by doing a 1 by 8 and then another 1 by 8 split. But as you see here in this slide, these are even splits, and you can do a lot with a 24 fiber cable here. So in this particular case, we're showing you can support up to 384 homes with 20 fibers distributed out in the system. So as we move from an even distributed split to an uneven distributed tap network, here we're talking about 2 layers of splitting again, but the first layer, this is uneven, and that uneven splitting allows for an even more lean architecture. So in this case, we're showing that 12 fibers can support 384 homes. That first uneven split, it typically is displayed in, we'll call it kind of a power ratio. So common uneven ratios are that the first split that passes through down into the next location is the higher number. So you might start off with a 90-10 split. The 10 would travel down into the even splitter. Those even splits can be the same ratios that you might have in your distributed split. So those could be 1 by 2, 1 by 8, 1 by 4 splitters. So you could feed 2, 8, or 4 homes at that location. Other common split ratios on the uneven side are 85-15, 70-30, and 60-40. Typically, the last terminal in one of these chains is not an uneven split. It's just more of a standard distributed split terminal. We'll show you a diagram of that here in a minute. So let's jump to the next slide, and we'll talk about the distributed tap architecture in a little bit more detail. So here's a diagram of a possible system. Here we're choosing to use a 1 by 8 setup, so we're feeding 8 homes at each terminal location. And as you see in the network diagram, we're starting off with an 80-20 split. We're passing through that 80 onto the next terminal and dropping the 20 down into the drop ports, those 8 ports, the 1 by 8 splitter. And so the next terminal is a 70-30, and then the next terminal is a 60-40, and then the final terminal, you don't have an uneven split, you just have your 1 by 8. So one of the key things that you need to consider here is your optical budget or your power. So we have a calculator that is capable of entering in your configurations, your parameters, and it will tell you, what the right mix is of power ratios to make sure that you can get light to the end of the system. One of the other great benefits here is that with the lean fiber also comes the potential to utilize plug and play connectivity and the small form factor of these terminals to deploy quicker and faster with less labor. And so that workforce shortage that you might have, this is one really quick, easy way to do more with the workforce that you have, so to deploy faster, get to revenue faster, and also potentially bring new employees and their training up to speed quicker because of its ease of use. So this could also be done with a 1 by 4 or a 1 by 2 terminal. Your situation, your network diagram, your network layout is going to kind of dictate which terminals that you want to use at a given location. All right, so let's jump forward to the next slide. Here we're taking into consideration key elements of a deployment. So In this particular case, if you're using, push lock drops in your distribution path, you might want to consider what your typical spacing is in between these locations. So what we're showing here is an aerial terminal setup. So you want to make sure that you can keep your terminals in a spacing that kind of supports our max length, which is about 600 meters or 1,800 feet. Another critical thing, just like any system, is you want to make sure you're looking at your sparing rules, and we recommend about 20% spare or potentially more in your feeder, because typically you're going to run down a road, you're going to set up an optical tap system, you're going to use that system, and then you're going to pass feeder down to start up another optical tap system. And so you really need to look at your network, plan for any future growth that may not be clear. We know in rural areas there's plenty of land, so you might have a neighborhood pop up. You want to leave some spares there to set up another optical tap run if you need it in the future. The other thing you want to consider here is to minimize the number of cables that are running parallel in the same path. We recommend keeping that to a maximum of 2, and that is simply to limit the load on poles if you're doing aerial, and to keep your system simple and easy to manage. The next thing is just, again, like any other system, you want to really consider slack loops for maintenance and repairs. If you're going buried, you can put these inside of vaults or pedestals. And if you're going aerial, snowshoes, Deltex straps, or setting these up at the pole, similar to any other system. Definitely want to consider that as you plan out your network. And then the next thing is, just like most systems, you want to really have a good plan in place to clean and test your systems. Vincent's going to go into more detail on the testing side, but you want to get a good system budget planned out, and then make sure that you're staying within that system budget. So testing and verifying your system after it's installed, making sure everything fits within your budget, your system's ready to go for the future. So we definitely recommend cleaning the ports as you install to make sure you get good clean connections. And also just from experience, you might consider using an attenuator at some of the first initial homes there if you're coming in too hot on your electronics. All right, so now let's talk about how within any system, how do you make sure that you're building for reliability in the future? So first and foremost, you want to make sure you know your environment, know your conditions. So the weather conditions in your area. If you're going aerial, what do you have ice loading to consider? If you're going underground, do you have a lot of rock? We're hearing from a lot of people that running in rock is presenting challenges. So maybe something like an alternative deployment method could present itself as a good option to bring costs down. Just like we've been talking about, architectures and split ratios. Do you have the right link budget for your optics, and what's your PON roadmap look like? Are you doing XGS PON now? Maybe exploring a 1x64 split, but do you want to go to 25 or 50 gig in the future? And how would that impact your network if you deployed those systems in the future? And just like we talked about earlier, is 20% sparing the right thing for your network? Do you see a lot of potential growth in your area? Do you have small businesses or even large businesses, factories? Is there a lot of economic growth in your area that you might think about serving? What about mobile systems or cellular systems? Do you have enough fiber to support a tower if it were to pop up? And then you want to make sure you're thinking about that not only in your cable, but also in your fiber distribution housing or your LCP, and also in your terminals and your port counts. The next item is a focus on build quality assurance. Building your system right the first time can ensure that you have operational efficiency down the road, that your system's really built to last. So typically people view a fiber to the home system as a long-lived asset. So you're thinking 20 to 30-year assets and maybe even longer. So like Vincent mentioned earlier, it's a future-ready system, and you want to build it right to save yourself time and effort down the road and make sure that your customers have a great experience. So with that, you want to also make sure you consider, don't overlook things like accessories and hardware. So this could be pole attachment hardware, clamps, accessories, using the right accessories, the right setups down in a handhole or pedestal to keep rodents and the critters out, right? And then build in test points and build with the operations in mind. So clearly, as you run into maintenance or troubleshooting needs down the road, you want to be able to get in your system, evaluate where the issue is, and evaluate it and get it repaired and back up and running as quickly as you can. And from an operations standpoint, you want to make sure that you're not putting yourself in a bad operational situation due to choices up front. So that we'll talk about in a minute. There's trade-offs there, but definitely talk to your operations folks. If you're in engineering, make sure you're talking to people in operations, that you've got them in mind as you're making decisions on how to build your network. And then think about your future labor situation. If you have trained people now, what might your situation be in the future? What's the workforce like in your area? Do you have skilled labor available? Is it quick and easy to get people? Do you have a lot of turnover in your technicians that are typically out installing this stuff? And keep that in mind. Again, if this is going to be a 20 or 30 year system, what are things going to look like off in the future? And then systems and procedures for proactive maintenance and repair. Vincent's going to talk about this in a little bit more detail, but you want to make sure that you've got this well documented, that you're training on this, and that you're ready to go. One of the things that we're hearing is a need to reduce mean time to repair. So build quality assurance is important in that. So build it right the first time, but also making sure that you have tools, systems, and procedures ready to go when an event happens, that you can keep the downtime to a minimum. And then redundancy in critical portions of your network. So this could be your backhaul and maybe your feeder portion of your network, but thinking about redundancy, building that in so that if something happens, you have the ability to cut over in critical parts of your network. All right, so as you can see here, we've got a lot to consider when we're looking to build a network. And the reality is that all of these decisions are really about trade-offs. There is no right or wrong answer. I'm not here to tell you that I know everything about everything. The reality is that you've got to consider what's right for your network and your needs. So knowing your network, knowing your company's priorities, and knowing your customer needs, the needs of your communities is important. So as you look at a few trade-offs, thinking about the trade-off between aerial and underground, are you running into challenges deploying aerial? What would changing to an underground network do for you? Maybe you could actually deploy it faster due to a lack of delays to working with poles, but maybe your costs go up. So that's something to consider. More fiber versus less fiber. We just talked about architectures. So one architecture gives you the ability to have more fiber in your network. The other one allows you to go leaner, and that comes with trade-offs, especially as you're looking at building a future-ready network. And then CapEx versus OpEx. So decisions to minimize CapEx up front could mean, potentially higher OpEx down the road. So that's something to consider. And then, again, what's your labor situation? So do you have plentiful labor now where maybe you could take on a labor-intensive approach, maybe with more splicing, but how's that going to impact you down the road if that labor force dynamic changes? So evaluating a labor-light solution with more connectivity, and that allows you more efficiency and more speed of deployment is something to consider. That might mean higher upfront CapEx, but again, lower OpEx into the future. And then your optics, if you think about current technologies, XGS-PON is growing in adoption. What is your path beyond XGS-PON, and what is the right split ratio for you? Are you considering a 1x64 in an XGS-PON system, and what might that mean for your future speeds that you're going to offer in your system? All right, so now I'm going to transition back over to Vincent here after we do this poll question. So we'll go ahead and jump into this first poll question. So in the past 18 months, what was the biggest source of outages or downtime in your network? Was it weather or natural disaster related? Did you have a network failure related to an active or passive piece of equipment? Did you have a connector fail or an OLT or an ONT fail? Did you have in-home issues like Wi-Fi or other challenges inside of the home? Was it construction related? So, self-induced construction outage, or maybe another utility damaged your system? Or was it something else that's not listed here? If it is something else, please share in the panel for the quick Q&A. All right, so I think responses are coming in. And so far what we're seeing is, weather and natural disasters leading the charge here. I think I was just talking to somebody about the tornado that hit in Tennessee recently. I believe it was in the Clarksville area. So we're definitely seeing a lot more weather and natural disasters. That's something to think about. So in that aerial versus buried discussion, you know, we've seen down in Florida, they've taken a lot of the network down underground to harden for hurricanes. So that's something to consider. There's a lot of news out in California with some of the recent wildfires and trying to underground power systems to avoid sparking wildfires. So that's something to consider. And then, yeah, the Wi-Fi in-home issue is not surprising. I think that's pretty consistent. We're hearing that from a lot of operators. So thanks for participating in the poll. We appreciate that. I'll turn it over to Vincent.
Yeah, thank you, Darren. That was very insightful. All right, so now let's talk about testing PON networks. So when we test balance splitters using today's tool, there's a number of ways to test those networks. There's OLTS, optical loss test set, there's OTDRs, and there's tools that will offer automation, such as IOLM, Intelligent Optical Link Mappers, that will basically be, if you will, an OTDR on steroid that will basically have the capability to figure out the network topology and send multiple pulses, multiple wavelengths to diagnose automatically what's going on in the network, what kind of components you have, depending on the optical behavior of the light traveling in the fiber. So that's an example here of a test tool available on the market that will allow you, instead of seeing an OTDR trace, which can be confusing for some users, especially if you have new workforce coming in, new employees that may not be experienced with fiber testing or OTDRs. So that's the kind of tool you want to put in their hands that will allow them to quickly and efficiently and accurately assess the network and all its components. So as you can see here, there's a graphical view that will allow you to see where are the faults, and if there's a fault, you can even have a diagnostic box like we show him in the bottom in yellow that will take you to the fault point, the distance to fault, and give you an advice on what could be the issue in your network. And here in this network, we see a network where we have two splitters that are balanced and distributed splitter architecture with two 1x8 splitters back to back. If you test unbalanced splitters, there's a reality we have to take into consideration, and is the fact that, as Darren mentioned, the split ratio will not be balanced in some branches of the splitter. So here is an example of what we talk about, where you have different ratio of splitting. Like here, we see the first stage is a 90-10, and then you have later down the road, you have 80-20, 70-30, 60-40, and so on and so forth. So that means that for the first one, if you look at the first splitter in the network here, we're dropping 10% of the light, splitting it within 8 subscribers, and there's 90% of the light that will go through the splitter to feed the subsequent unbalanced splitter on distributed tap. So when you test this with an instrument, an OTDR or an OLTS or any other tool, this is meaning that you will face various insertion loss at the splitting location. So as you will change the splitting ratio, you will change the loss behavior on each branch of the splitter. So this is where it becomes very confusing for the workforce, because you have to know what you are expecting at this location to properly assess the health of this tap location. So in this example here, we have, as you can see, 11 dB loss for one branch and 0.7 dB for the second branch. And as you go down the network with various splitting ratio, you can clearly see here that this insertion loss behavior will change depending on the tap location or the tap ratio. So this is meaning that you will have to have a tool that will allow you to set the instrument with the proper elements so it can properly assess the quality of each tap location. So in this view here, we see another component that was not there in the balance splitter testing is the tap ratio. So you see the 55-45, the 70-30, the 80-20, and this is another component that you have to enable in your test tool to make sure that you properly assess the pass or failed, so the quality or the health of each component within the network. So again, here, there's the traditional way on the left side with an OTDR graph. As you can see, it can become hard or confusing to interpret, as you will have a behavior that will basically be very similar from a tap to another, basically just an insertion loss, a drop in the OTDR trace. If you use a tool that will allow you to input tap elements, then you can have an automatic assessment of each component on your network and a graphical view that will correspond to what you have in your network. Another challenge with distributed tap architecture or PON architecture is the topology or the correlation between different icons that you will use when you engineer the network and the ones that you will be using to test and then to produce the report. So here is another example of a customization you can do in your testers. In traditional HFC network, we've seen different icons being used for different port tap count, such as a circle, a square, an hexagon, octagon, and so on and so forth. That will basically correspond to how many branches or what's the split ratio of the splitting location. So that's another view you can enable in today's tool that will basically allow you to customize the view of your, not only the trace, so the view in your tester, but also having these icons clearly identified in the report as well. So when you hand out the test result to the network owner, which could be different if you're using contractors, for an example, you can easily correlate what's being engineered with what's being tested and what you see in the report. So now let's go to another poll question. So as I just mentioned, there can be various crews handling the network install. So this poll question is about who will handle your network construction. Is it A, external contractors, B, internal installation crews, or C, a mix of both? So basically doing it with your internal crew and using subcontractors or external installers. So here we clearly see a leading answer, which is basically a mix of internal and external installers. And that's not a surprise. That's the behavior we see in the market today. And also external contractors is the second one. So that is a great segue into the rest of my section about cloud management and network automation, and not network automation, but test instrument automation, which basically facilitate the collaboration between various crews. So first answer, the most popular is the mix of internal and external installers. Second one is external contractor, and 8% voted for B, internal installation crews. So that brings me to this point here about collaboration between the different entities that could be involved into a project deployment. Here we have 5 components into this synergy here, where you first have a project manager that can create and define jobs. And this project manager could be an engineering firm or an external firm that will manage your project. This manager can create jobs that will basically be fed to the installers in the field, which could be internal or external, as we just saw in the poll question, which basically will include the correct file naming, the correct test configuration, to make sure that the force that basically operates the instrument will use the right settings for their test equipment and the right naming that will then be reflected in the report. Then you can have site lead or field manager, and these manager will want to monitor the progress of each of their crews depending on the size of the project. And then you have results auditors. So that could be an engineering firm that did the network engineering and then will want to make sure that the network will basically meet the requirement before turning it over to the network owner. And then you can have an operation director, a system engineer, or any other entity that will want to have a global view on the job progress, on how many connection points are installed, what are the results, are they failing or passing, is there a crew that will need more training, for an example. This is all insights you can have if you have automated field management and cloud connectivity within your tester for jobs and also for test results management. And that's one of the way to basically connect all the parties involved in a project deployment. So now if we talk about maintenance and troubleshooting, we've talked about network construction, doing it right the first time, testing at the build. So here we'll be reinforcing that point. If you deploy a distributed tap architecture, most of the time we've seen deployments that will happen in different phases. So basically, and that's the beauty of this kind of technology, you can deploy components as your network will grow, as your customer will subscribe to the services. And that means that you can have portion of the network that will not be installed from day one. Specific taps may be installed as subscriber or added to the network. And the reality we have to keep in mind is to make sure that we properly assess the health of each component as we install those in the network. So as an example here, if I'm trying to activate the service at the end of the line on the very last tap location, and I'm having an issue at this point. Let's say, hypothetically speaking, that we have a problem with the 9010 tap location, 30 connector, or any other issues, and that component needs to be serviced. You may affect the service at a specific location, upstream in the network, and you don't want to do that because you have active customers at this location. You can have potentially, in this example, 8 customers active at this component. So here it's really important to understand that you really have to assess the quality of each of your component as you install them in the network. So doing it right the first time is the way to go. Making sure that you have the proper test equipment, again, that will allow you to test, in this example, the distributed tap will easily allow you to visualize what's going on in your network, what's the faulty component in your network. Also, one thing we have to talk about is when you activate customers is the need to make sure that you have the proper test equipment. If you deal with a contractor or construction crew, most of the time you will have technicians that will basically be more experienced than when you do broadband service activation. And that's an issue we have to keep in mind. If you activate the service, you may deal with another type of or another persona in your crew, another type of technician that may be less experienced with fiber. They will have to deal with Wi-Fi testing, throughput testing, installing the ONT at the customer location, and also troubleshoot fiber. So it's just part of their tasks. So you got to use the proper test approach here. Unfortunately, we've seen in the field many instances where there was a no test approach. So basically, the technician didn't have the proper test equipment in his hands to properly diagnose where is the issue. So if you have an issue somewhere in between the customer and the splitter location, is it the fiber? Is it a bad patch in the panel, connector reversal, stuff like that? You will have basically to drive at each of those locations or walk at each of those locations, depending on the distance of where the patch here of the fault is. So, and this is not efficient at all. So that makes for a customer that are quite unhappy with your service. There's a new type of tester that has been introduced in the market a few years back, which is called a multimeter. And this is basically a tool that will enable you to pinpoint the location of a fault. But it is not an OTDR per se. It doesn't bring the complexity or the cost involved in buying an OTDR, for example. A multimeter will allow you to test a number of things. Power levels will give you distance to fault. So with that information, your crew will be empowered to quickly locate the fault, like in this example. We can locate the fault. Hypothetically, it could be at the splitter, a bad connector, a dirty connector, or something like that. And you can quickly resolve the fault by knowing exactly where it is. So this is what we call the multimeter, and it's a very useful instrument to have in your crew when they're doing broadband service activation. So we've talked a little bit about cloud connectivity and how we can connect the various persona, the various crews involved in network deployment. So here's an example of basically the food chain when you deploy networks. You will use an IOLM or an OTDR to test the fiber when you build the network. Intelligent optical loop link mapper will enable you to do automatic assessment of your network without the need for deep trainings. And Exchange, which is our cloud management solution at EXFO, will bring visibility for each of the parties involved into the network deployment. We'll connect the entire ecosystem together, job management. You can have centralized results that will be available for engineering firm, network operator, enabling to see the progress when you deploy a network, and also with the analytics to take corrective action. If you see a crew having trouble doing retest, doing additional truck roll to solve the issue, then this can give you insights on maybe there's a team that needs more training, they don't use the proper equipment, or they have problems in their methods and procedure. So analytics is also a very big piece of having a team that is connected together through solutions such as Exchange. Fiber multimeter, as I said, can give you a lot of visibility on your network, easy to test, easy to operate, basically a one-button test approach, which will basically be completely automated. Inspection probes, as the network grows, you have to make sure that your connections are in good shape. Connectors is unfortunately a place where you can have issues if you touch them, if you don't handle them properly. So having an inspection probe is a very simple way to alleviate issues at this stage. As Darren mentioned, proper cleanliness of a connection point is very important to ensure good performance of the components and the network itself. So here comes the last poll question. In the area of workforce deployment and fiber optic skills, what do you see as the biggest need for training? Is it A, fiber 101, B, fiber troubleshooting, C, PON, fiber to the X 101, D, managing fiber test results and reporting, or E, all of the above? All right, so the results are in. The leading answer is E, all of the above. That's a trend we see in the marketplace. We've been very active, delivering seminars and training to customers or entities around the world involved in fiber deployments. So that's an area where we're very active right now. A lot of new workforce and a lot of new technicians being hired. There's hundreds of thousands of people that will be hired to deploy fiber around the BEAD initiatives and other funding initiatives. So that's no surprise. The second leading answer is PON FTTX 101. The third one is fiber troubleshooting. And then we have 5% on B, on managing fiber test results and reporting. All right, so thanks for answering the poll. So now just one last slide as closing remarks. Using automated test instrument to alleviate pressure on workforce is something to consider, especially if you hire new people in your workforce and you want to make sure they all follow the same methods and procedures. Having automated test tools will facilitate that. Application-centric instruments, as we've seen here in this deck, we have OTDRs or ILM that will be adapted to different tasks to test balance or unbalanced tap with different elements in the software itself to properly assess the network. Cloud job and results management will enable fluid workflow between internal and external teams, especially if you use external contractors or external crews, as we've seen in the poll. That's a reality. Having a cloud connectivity solution will enable you to have visibility on the progress of your different crews and you're involved in the network deployments. Proper testing at the network install, as we've seen, will favor a smooth customer experience. Make sure that when you activate customer, as your network will grow, that you will not run into issues that could potentially affect customers that are already active in your network. Back to you, Darren.
Yeah, so wrapping this up, you know, one of the key things that you've got to do is just assess your network and customer needs, and then develop some guiding principles. Make sure everyone's bought into that, and let those guiding principles help you out as you evaluate your trade-offs. Next one. So when you develop those guiding principles, it makes it easier to evaluate those trade-offs and make good choices. We talked about a lot of the trade-offs earlier on, so things like aerial versus buried, what PON technologies are you going to do now and in the future, things like labor considerations, labor light versus labor intensive solutions. So really, you know, spend time, bring as many people in to consider that, and then, you know, with the future labor and funding environment, we know there's a lot of funding coming in from various sources, but what are things going to look like 10 years from now? As you're operating the network, do you have a network that requires a lot of maintenance and repairs, or do you have a system that's running pretty smoothly because it was built right the first time and tested and with high quality build quality assurance? All right, last one. So the other thing too is really focus on building a team that is ready to deliver the best customer experience for the future. I think it's something our industry is really keen to do, is to build great customer experiences, and we believe that, you know, fiber is the best path to delivering that future-ready network and get the best experience to people and connect the unconnected. All right, so we'll wrap up here and take some questions. Thanks for joining us today.
All right, well, thank you very much, gentlemen. That was great. And we do have some questions that came in here. I think many of these were addressed, but we'll go through some of them here with the time that we have. So the first one here is, how can we ensure the customer gets good Wi-Fi connectivity and good bandwidth? Yes,
I can take this one, Darren, and talk about it in terms of testing. And that was one of the insights in the poll, by the way, where we had a lot of people identifying Wi-Fi being an issue when you turn on networks. We didn't touch base on this in this presentation here in this webinar. We didn't have time, did not allow to talk about this, but maybe that could be the subject of a subsequent webinar in the future. But there's testers that will allow you to properly assess Wi-Fi connectivity and throughput in various locations of the homes, such as, for example, in the living room. If you know you have a 4K home theater that will be installed there, there's tools like what we call it EXFO EX service testers, EX10 for 10 gig. You can have testers that will enable you to test up to 10 gig Wi-Fi 6E. Also, and make sure that you have a tool that will enable you to test the throughput in various locations of the homes to make sure they have proper connectivity and throughput as well, which is often something neglected at the time of service activation. Yeah, so there's tools for that, multi-service testers that are also cost-effective, portable, handheld, that can be part of the toolbox of any broadband service activation crew.
Yeah, I think one thing to just add on to that real quick, David, something that we're seeing is I think a lot of operators are looking at offering managed Wi-Fi services, and I think that people are getting better experience through that. And so I think that's another thing to watch for is can a managed Wi-Fi service help enable better service, better quality for the homeowner.
Great. We also had one come in here too that's related. So when you take 20 strand fiber and you can now serve the same number of homes with the 12 fiber. What about the quality of services? How can we ensure that those homes are still getting the right quality?
Yeah. So back to some of our themes here, testing the system and making sure you build it with quality in mind, and kind of know what your system limits are. So I think if you do that, you're still going to be able to offer, your most common speeds and systems, right? So whether that's 300, 500 meg, going up to gig, multi-gig systems, even with those types of systems, you're still going to be able to offer speeds and good quality service. So again, you want to really make sure you understand your budget, your PON equipment, what it's capable of. And I think you put that thought into engineering, planning, designing up front, and you're going to be able to deliver good quality services.
Great. I think we have just time for one more here. We did have a lot of questions come in, but we'll be sure to respond to those if we can following the webinar. Does EXFO provide training on fiber broadband test and maintenance?
Yeah, that's a good question. Yes, we do have programs available which are could be on-site to your crew, organized on-site, and we'll also have on-demand training on our website, which is available 24/7, and it's free of charge as well for contractors. We have a mix of chargeable or free trainings depending on your needs. Yes, we do offer this, and yeah, we are ready for that at EXFO.
Yeah, Dave, it's probably a good time to plug the Optic Path program too, right? With FBA,
Yeah, that's right.
There's a lot of great workforce development initiatives going on. So, if you don't know anything about that, look into the Optic Path program. Lots of great capabilities there as well with the FBA and their partners.
I appreciate that, Darren. Absolutely. That's a good option. With that, I think we do have to wrap it up. We're right near the hour here. I just have a couple of quick announcements before we go. First of all, registration is open for our first Fiber Connect regional workshop, which is happening on February 8th in Richmond, Virginia. So if you are in that area, we would love to see you there. I certainly plan to be there. And then as far as the rest of the calendar goes, we have more of those regional fiber workshops coming up. We've got Little Rock, Arkansas in April. Then at the beginning of summer, we'll be in Deer Valley, Utah. Des Moines a little bit later in the year, and then Albuquerque will be our last one closing up 2024. But in between that time, in July, we hope to see you in Nashville, Tennessee for our Fiber Connect conference, our big conference every year. So look forward to seeing people there. To learn more about Optic Path and all of the things happening within FBA, I encourage you to check out our Q4 edition of the Fiber Forward magazine, which was just released. There's also one in the handouts here, a download that you can download today. So definitely check that out. If you want some more reading, we also have our Playbook 3.0 for broadband infrastructure has been finalized. So use that QR code and you can gain access to that valuable resource as well. We have our Fiber for Breakfast series and all of our other webinars coming up. Fiber for Breakfast is hosted by Gary Bolton, the FBA President and CEO. So we hope to see you there. That's every Wednesday at 10 a.m. And with that, I just want to extend my thanks again to Darren and to Vincent and to EXFO and Corning for sponsoring today's webinar and providing this great information and insight, helping us all connect some of those unconnected communities. So I really appreciate that. And of course, appreciate everybody joining today as well. Please fill out the survey that you'll see in just a moment. We appreciate that feedback so that we can constantly improve these and make sure that they're valuable for you. So thank you again, everybody. Have a great day.
Thanks.
Thank you.